Alright, this is one of the IGCSE past year question. I think it's a 2016 October-November paper 2 for additional mathematics. Alright, this is question 10, and yeah, of course this is one of the questions my Facebook student actually asked me. Yeah, I guess he or she actually say this question is quite hard. So yeah, I'm trying to help out in these questions. So yeah, this is 7-mark question, but I will involve a lot of explanation in this video. Yeah, especially for the first part. Yeah, you will find out why I need to explain so much for the 2-mark, but then it's so important to understand this kind of questions. Alright, so yeah, let's go into the question here. Right, so the first thing is the town Cambly is 5 km east and p km north of Edwin Town, so that the position vector of Cambly from Edwin Town is 5,000 and 1,000 p meter. Alright, so from here, actually something you have to pay attention is the unit given here is actually meter, but then the first sentence is actually given you the km. So you should understand this one actually means 5,000 meter, and this one actually means 1,000 p, because this is 1 p km. 1 p means 1,000 meter p. So this is how actually they get this thing. So the first thing I will try to get you some information. What is the meaning for 5 km is? So basically, you have something like 5,000, and then due north, which is 1,000 p. Obviously, we do not know what's the value of p. If p is 2, then this one will be 2,000. Okay, so I just assume something like this. Alright, so this is from I guess the town of Cambly. So I think this is Cambly, and then this is Edwin Town. Alright, so basically this is from if you want to from Edwin Town want to go to Cambly, so basically what you need to do is you have to this is something position vector. Position vector means the position. Okay, the position of Cambly actually is 5,000 and 1,000 p meter. Alright, so you should understand what is the meaning of position vector. Position vector mean basically is a position, and then the position vector is very important to know which one. Okay, the position vector is actually built from what? So like if you have the Cartesian plan, we know all the coordinate is built based on the origin. So but then in this case, everything is relative to the Edwin Town. Later you do the question, you will understand. So you have to assume the Edwin Town, this one is something like your origin. Mean all the coordinate is the position vector, and then they must relative to the Edwin Town. Means the Edwin Town is like origin, and this origin we're going to tell you like what is the other position vector. So same thing like this one can be. This one can be actually the position vector is from the Edwin Town as well. Alright. Anyways, if you don't understand, let's move on to see what happened next. So Manjit set out from Edwin Town at the same time as Ra set out from Cambly. So you have one person, which is Manjit. Actually, you will you will actually set out from Edwin, and the other person actually will set out from the Cambly. Alright, and then now Manjit set out from Edwin Town on the bearing of 20. So obviously you have to know about how to do 20. So from Edwin Town here, I trying to draw a north at Edwin Town here, because I want to give you some idea about 20. Okay, it's about 20 degree. Right, from the north. Right, so at a speed of 2.5, so I will get a velocity of Manjit basically is 2.5. Okay, heading this direction, I guess. Alright, so that her position vector relative to the Edwin Town after t second is given this one. So I need to explain about how this position vector come from. Then only you can do the first part, because they will ask you to find the position vectors of Ra relative to the Edwin Town. You always see something relative to the Edwin Town. Right, because this one for the For the Manjit, basically it's very easy because for the Manjit itself, it's actually depart from the Edwin town. But then for the Ra, it actually depart from the Cambry, but you need to relative from the Edwin town. So this is a little bit different. Okay, anyways, how actually they get the position vector, this one, is basically you have to form a triangle by yourself. So I hope you can see a triangle in blue color, and which is 90 degrees, something like that. So I will actually draw out this triangle at the bottom here and give you some idea. Okay, so you see the triangle, so I will draw the triangle here. So this is 20 degree. So I will assume this is 90, not assume, I know this is 90 degree, and this is 70 degree. Alright, so and then we have a speed here, which is 2.5. Alright, so if you want to do the position vector, of course the first thing you have to understand that position vector actually will equals to something like velocity multiplied with time. Mean you have to find your velocity in the vector form, column vector form, so which is something like you will do x and y, and you will multiply with time. Alright, and then obviously over here they say after t seconds, so you just multiply t. Okay, this is how we find a position vector. Alright, so now I want to find the velocity first. So velocity, we normally will do x, then we will do y. X mean actually moving right or left, and y actually moving up or down. Okay, it's something like that. So in this case, my x is basically this one. So I will call this one x, and then this one is my y. Right, because you can see the position vector here, everything in cos. So I just trying to use the cos here. So in order to get x here, and I want to do in the cos term, so adjacent, you should know the basic. Basically something like cos angle equals to adjacent over hypotenuse. Right, so over here, if I want to find x, I have to use a 70 degree. I cannot use the 20 degree because 20 degree will give me a sine. So I trying to do something like cos 70 basically will equals to x adjacent over hypotenuse. So my x is basically 2.5 cos 70 degree. Alright, so I will do the same thing for y. So in order to get the y, I have to use a cos 20. So cos 20 equals to y over 2.5. So basically my y equals to 2.5 cos 20. Alright, so this one is basically my velocity. So I get the x and y, right? So if I write my velocity over here, I will say my x is basically 2.5 cos 70, and then my y is basically 2.5 cos 20. And I want to get a position vector, I will multiply with time. Right, so therefore you can get this thing, 2.5 t cos 70 and 2.5 t cos 20. Just multiply the t into it, so you will get a position vector. Alright, this is how the position vector of the Manjit depart from the Edwin town after the t second. Alright, so how about Ra? Okay, Ra will step out from Cambry. So I will choose a favorite color for Ra, maybe green color. Okay, so Ra actually will step out from Cambry on the bearing of 310. So basically you have to understand how the 310 will look like. Okay, so this is 270, 310 basically is something like this. And then here is 50 degree because the whole thing is 360. So basically, if this is the north here, I know basically this is how it will look like for 310. And here is definitely 50 degree. Because here, the angle here will be 310. Yeah, will be 310. For this one, I hope you can see. Alright, I hope you can see. So from here, basically, yeah, you can see a triangle. Yeah, the triangle is not very obvious, but the green color triangle here. Okay, I hope you can see this triangle. Alright, later I will draw out this triangle in order to get this vector. But then just now I say this vector is actually depart from the Cambry, but then the question actually asks you to find a position vector of relative to the Edwin town. So that means you will need to find a position vector relative, mean how the move is relative from the admin tau. So that means this is the line you need to find. Okay, because this one is relative to how actually the ra step out. Alright, so and relative to the admin tau. So you need to find this vector. Just assume this is a resultant vector. If this is a resultant vector, the black color one, you know basically you need to use this vector plus this vector. Correct or not? Because if this is a resultant vector, you just need this vector plus this vector. This vector we have already. This is the vector he given us at the very beginning. The position vector basically is 5000 and 1000p. But then we don't have the green color one. Okay, so I will just do it at the bottom here using the same idea. Okay, so let's do it. Okay, let me use back the green color just not to confuse you. Okay, so I will try to draw out the triangle. So here is 50 degree, and then the velocity I think is given. The velocity is 2. Alright, so here will be 2. This is 90 degrees, so I know here is 40 degree. Alright, so same thing. In order to get the velocity, I will need to do the x and y thing. So x is basically this one. This is x. And this is y. Alright, so yeah, this is something like x and y. So yeah, so I will use back the method just now. So you should know in order to get this as an adjacent, so I will use the 40 degree. So and then I will multiply with hypotenuse. So this is 2 cos 40. And same thing, in order to get an adjacent y as an adjacent, so I will use 50 degree. So you multiply with the hypotenuse. So basically the y is equals to 2 cos 50. Alright, so yeah, just use back the same method we do just now. I just a bit shortcut here. So yeah, this is 2 cos 40. And then my y is basically 2 cos 50. And multiply with time. Okay, so yeah, we'll get something like 2t cos 40 and 2t cos 50. Alright, this is the green color vector, which is this vector. So in order to get these 2 marks, so what I will do is basically I will try to take this vector plus this vector. So yeah, so the answer for first part, yeah, so I will say, yeah, position vector equals to, yeah, just now is 5000 and this is 1000p. Okay, because this one already is a position vector, so this is a position vector, so I will just plus with another position vector with 2t cos 40 and 2t cos 50. Yeah, you might have the questions like, can I use a sign to actually do it? I guess you will get the same answer. Yes, I think you can use the sign, but I checked the marking scheme, they use a cos, so I will use a cos here. But I think if you use the sign or tangent to do it, you should get the same answer. But you can't use tangent because you have to use the hypotenuse line. So either sine or cos only. Alright, this is 2 mark here. Yeah, I guess actually we should have the faster way to actually straight away get this one. Yeah, but in order to make you understand, so I actually go a long way to actually explain to you how to get this 2 mark. Alright. Then, okay, so we know this one is a position vector of ra. Alright, and then just now we have it's given this is the position vector for manjits. Alright, so okay, so we can do the second part. So they say manjit and ra actually meet after t second. So find the value of t and p. So yeah, this one basically is the position vector of manjit. Alright, so okay, so this is a very important words, meet. When they meet after t second, so in order to make them to meet, they must meet at the same time because they step up from the same time. So if let's say they meet after 50 seconds, both of them will meet each other at the same 50 seconds. So meet over here means same t value. mean they will meet at the same time. So because they have the same t value, so therefore we can substitute into each other. Not only same t value, mean also mean another thing is they will at the same position vector. Because in order to meet your friend, both of you must actually go at the same place, right? In order to meet them. So that means both of them have to at the same time and same position vector. Okay, same place and same time. So must be same t value and the same position vector. So therefore, I can substitute their position vector into each other to find my value t and p. Alright, so this is the position vector of Ra. So I will substitute the position vector of Manjit here. So yeah, because both of them also relative to Edwin Tao, so yeah, it's okay for me to substitute. So this is 2.5t cos 70. So we have a, okay, so now I'm doing the second part. So this is 2.5t and cos 70, and the other one is 2.5t cos 20. It's not mistaken. Let me just double confirm. Yep. So this is the position vector of Manjit, equals to the position vector of Ra. So I will just join them together, just easier from my calculation. This is 5000 plus 2t cos 40, and then this one is 1000p plus 2t cos 50. Okay, so yeah, so we just solve this one. We should be able to get the correct answer. Yeah. Yeah, I hope I didn't make any mistake here, but just let me double confirm the. Okay, yes, because I did this question before, so actually I realized I have a little bit mistake over here. Yeah, because we know that the position vector, I mean we know that the for the vector, if not the vector, actually the Cartesian plan. Okay, so we know that the Cartesian plan actually moving this direction is negative, because we know for x value is moving this one, x, I mean if going to the right, x will be positive, going to the left, the x should be negative. So over here, actually I did a little bit mistake is, yeah, this one should be negative. Yes, this one should be negative. Yeah, because going this direction. Okay, if the opposite direction, because this one go to the left, so it is negative. So this one should be minus. So this one should be minus. Alright, yeah. Okay, then let's continue. Yeah, I'm sorry about the silly mistake. So yeah, this one you just use the calculator. That means you just do something like 2.5. You just do something like 2.5 multiply cos 70. Make sure your calculator in degree is not radian. Should be in degree. So it's something you will get like something like 0.855 t. Alright, so then I will do the same thing. 2.5 multiply the cos 20. This is 2.349 t. Alright, well, equals to this one. Okay, I will say this is 5000 minus, okay, 2t. That means 2 multiplied with cos 40, 1.532t. And then I will do the same thing for this thing. So this is plus 2 multiplied with cos 50, is 1.286t. Alright, then this one, so you're comparing the x with the x, it means you basically you just make them as one equation. So 0.855t will equals to 5000 minus 1.532t. Alright, then this one minus to the other side with plus. So I will just use 1.532 plus 0.855. Alright, so yeah, over here you will get something like 2.387t and equals to 5000. And then I can get my t easily by 5000 divided by the answer. So you will get 2095 seconds. Alright, so after you get the t, you should be able to get the p easily. just like substitute the t into the second equation. So it's 2.349 t is 2095 will equals to 1000 p plus 1.286 2095. So you just solve this equation, you should be able to get the p easily. So yeah, 2095 multiplied with 2.349. Okay, so 4921.155 minus this value 1.286 multiplied with 2095. Yeah, you will get something like 2694.17 equals to 1000 p. So yeah, just do the simple minus with your calculator. Minus 2694.17. So yeah, you will get something and divide 1000. Yeah, your p should be 2.23. Alright, this is how to do this question. Yeah, for the whole video actually, yeah, I make a little bit mistake. But anyways, yeah, the idea is always the same. So first thing is you always need to understand the position vector is actually vector of velocity multiplied with time. Alright, and then yeah, for the vector, yeah, you should know that yeah, move to the right is positive, move to the left is negative, up is positive, going down should be negative. Alright, so I think that's all for this video. If you still cannot understand and you think which part is very confused, please let me know. Yeah, I hope I can improve my video. Yeah, thanks for watching.